Welcome, students. Hello. This is our lecture on drug calculations. And I'm going to do my best to hopefully make this simple and easy and fun. Because I think it's fun. All right, so metric system is what we always use in the healthcare setting. Okay, and a lot of people are not familiar with the metric system because it's not typically what's used in our everyday lives in the United States of America. But majority of medication, calculation, and administration, you need to be familiar with the metric system because that's what we use because it is more accurate. So that's what we use to administer medications safely. Okay, so right here, you've got your English measurement equivalents, which is what we're most familiar with, and then their metric counterparts. So we are used to measuring things in inches or feet as far as size and length, and the metric equivalent would be meters and centimeters. We're used to weighing things, solid objects in ounces and pounds, and in the metric system, we weigh in grams and kilograms. And then in liquids that we measure out in cups, quarts, gallons. But in the metric system, we use liters and milliliters. And then we measure distance in miles, is what we're used to. On our car, we have our miles per hour to calculate our speed. And then in the metric system, we use kilometers. Okay, so the metric system is based on the decimal system in which everything is divided and multiplied by tens. So it's actually pretty simple once you kind of understand that. So the three basic units of measurement are for solids, we weigh in grams. For liquid, volume is measured in liters. And then the basic unit for length is a meter. And drug dosages are calculated by using the metric measurements that relate to weight and volume. So the gram is abbreviated as a little g. The microgram is mcg. The milligram is mg. That's when we use all the time, right? Kilogram is kg. Liter is a capital L, a big L. And then milliliter is a small m, and then that capital L for liter. Okay, there's some basic prefixes that we can understand and add on to any of these basic units right here. Okay, so kilo means that you're going to multiply it by 1,000 times. Milli means that you're going to divide it by 1,000, right? So it's a fraction, 1,000th, so it's pretty small. And then micro is really, really, really small. You're dividing it by 1 million, so it's 1/1,000,000th of a part. Right here, that's a very small number. Okay, so for volume conversions, 1 liter is 1,000 milliliters, because remember, milli means to divide by 1,000. 1 gram is equal to 1,000 milligrams, because remember, milli is divided by 1,000. And then 1 milligram is equal to 1,000 micrograms, because remember, micro means to divide by 1 million. And 1 kilogram equals 2.2 pounds. So if we need to convert from kilograms to pounds, or usually we're converting from pounds to kilograms, say your patient weighs 150 pounds. So how many kilograms is that? Well, we're going to take 150 and we're going to divide it by 2.2. Okay, and that is 68.18 and then 18182. So we're going to round that up, right, to 68.2 kilograms is how much our patient weighs in kilograms. And then if we want to convert from kilograms to pounds, so say our patient weighs 200, no, that would be a lot, sorry. Say our patient weighs 90 kilograms. We're going to take 90 and multiply it by 2.2. Okay, and that's 198 pounds. So that's pretty easy. If you can just remember 2.2 is the conversion. All right, so our basic formula for calculating drug dosages. This is one that you're going to want to memorize. Okay, so it's dose over on hand times the quantity. Okay, so I usually set it up like this. D over H times Q. And then we'll have our answer. Okay, so D is whatever the provider ordered. So that's what you want. And then H is whatever you actually have on hand. So what's available to you. And then the volume that measurement is mixed into. Okay, so we'll practice this. So first of all, we need to be able to read the medication labels. Super, super important. So when we're looking at it, we need to find the quantity, the dosage that's measured out on the label, right? So that's right here. So in this bottle, this vial, that is 5 milliliters total, there's 20 milligrams of this medication, irinotecan hydrochloride, right? That's the medication name right here. So there's 20 milligrams of that in each milliliter per 1 ml, right? So we can think of this as 20 milligrams in 1 milliliter. Okay, and this vial has 5 milliliters in it total. So how many milligrams is in this whole vial? I usually like to figure this out, right? So how can we know that? Well, if there's 20 in 1, if we take this number and multiply it times 5, right, then we'll have 100 milligrams. So that's how many milligrams is in this whole vial, which is good to know, right? Okay, so this one right here, methylprednisolone, right? That's the name of the drug, injectable. It has 40 milligrams for each milliliter. And this vial is a multi-dose vial with 5 milliliters in it. So 5 times 40, right? That's how many milligrams are in the whole vial. So it's always good to know, right? 5 times 40, there's 200 milligrams in the entire vial. Okay, this one for Ativan or lorazepam, there's 2 milligrams for each milliliter. And this must be a large box, right, that has 1 milliliter vials, but 25 of them total. Okay, so each milliliter contains 2 milligrams of lorazepam. So this is a single dose, probably a single dose vial with 1 ml in it, each one. All right, buprenorphine hydrochloride, 0.3 milligrams per 1 ml. Okay, and there's 1 ml in the vial. So hopefully this is the amount that your provider is going to order, but you never know. But if they don't, we'll know how to convert it. Okay, digoxin, there's 500 micrograms per 2 mLs. And this is nice because they actually converted it to milligrams for you already, right? But the way we would do that is just divide by 1,000, right? But it's 0.5 milligrams in 2 milliliters. And this is a single ampule with 2 milliliters in it. Okay. So if we don't need to make any metric conversions, this is how we're going to do our dosage calculations. So the physician has ordered 10 milligrams of a medication to be given subcutaneously. And the medication comes in a multi-use vial. Okay, so this is important to note. It's 5 mLs total. And the label reads 15 milligrams per milliliter. Okay, so that's a different amount than what was ordered. So we're going to need to make a calculation to know how much of this to inject subcutaneously into the patient, right? So if we set it up with our dose, okay, with our conversion formula here, the dose ordered is 10 milligrams, okay? Now we're going to put that over what we have on hand, and that is 15 milligrams. That's what we actually have in our hand. Okay. Now we're going to multiply that by the quantity that we have. So for each 15 milligrams, it's 1 milliliter. All right, so we're going to multiply that times 1 milliliter to get our amount. Now, these cancel each other out, right? Milligram and milligram cancels out. And so we just have to do 10 divided by 15, which is 0.666666667, right? That's a lot. Milliliters. Well, there's no way we can measure out that. So we're going to round it up. Usually the nearest tenth is sufficient. Okay? So that's going to round up to 0.7 milliliters. That's how much of this medication we're going to draw up out of the multi-use vial and administer into the patient in order to give them 10 milligrams of the medication. Okay, let's try another one. So the physician orders 60 milligrams of Solu-Medrol. What you have on hand is a 10 milliliter multi-use vial, and the label says that there's 125 milligrams per 2 mLs. Okay, so how do we know how to give 60 milligrams? Okay, so our dose ordered, right, is 60 milligrams. We're going to put that over what we have on hand, which is 125 milligrams. And we're going to multiply that by the quantity, which is 2 milliliters. Okay? And again, these cancel each other, and we do your work left to right, right? So 60 divided by 125 is 0.48. And now we're going to multiply that by 2 milliliters. Okay, and so we have 0.96 milliliters. All right, so it would be pretty hard to measure that out unless we had a tuberculin syringe, right? Something really small. So we'll round it up to 1 milliliter. That's how much we're going to draw out of this 10 milliliter multi-use vial so that we can administer 60 milligrams of Solu-Medrol. Okay, so sometimes we need to convert from one unit of measurement to another, and that's known as a conversion when we change that. We often have to do that in order to prepare the correct dosage. Okay, so these examples we didn't have to convert at all, so they were super easy, right? But we have to do it when what was ordered is 1 unit of the medication, but the label has a different unit of measurement. So, for example, the physician orders 400 micrograms of a medication, but the label gives us the strength in milligrams, right? So we need to convert from micrograms to milligrams so that we know how much to administer. And we use our conversion factors here, right? So we know that this equals this. So we can use these in our equations to convert. Okay, so for example, the physician orders 0.5 grams of a medication to be given IM, and the label on the medication says that it's measured in milligrams, right? So we need to convert milligrams to grams. And we can do that because 1 gram equals 1,000 milligrams. Okay, so we're going to set it up like this. We want to go from 0.5 grams, and we have 250 milligrams, right? So we're going to stick in that conversion factor there before we take care of the amount, the quantity. So this is still dose over what we have on hand times the quantity, but we're just adding in that conversion factor in between. Okay, so we're going to set them up, always set them up opposite from each other. That's how you can get them to cancel out, right? So this gram cancels out this gram, and this milligram cancels out this milligram. So we know that 1,000 milligrams is the same as 1 gram. So now we can do our math, start from left to right. Okay, and so we go, say, 0.5 divided by 250, okay, which is 0.002. And then we're going to multiply that times 1,000. Okay, and these have canceled out. Milligram, milligram cancels, gram and gram cancels, so we can forget all of those. Okay, and that gives us 2. Okay, now we need to remember to multiply that times the 2 milliliters that comes in right here. So 2 times 2 is 4, right? Oops. 2 times 2 equals 4. So we're going to draw up 4 milliliters of this medication here in order to give 0.5 grams of the medication. So it's just an extra step in there, right? And here's another way of thinking of it. .5, you can put them all together into one when you cancel these out. Milligrams, milligrams, grams, grams, and then you can put them all here together. 0.5 times 1,000. See, I did that step first, right? And then times 2 milliliters, and then divided by 250, right? And we end up with 4 mLs. Okay, I'm going to pause this video to give you a little break, and then we'll try some more problems together.